This video is going to discuss factoring trinomials. And a trinomial is a polynomial that has three terms in it. And we are going to focus on trinomials where the leading coefficient is 1. In other words, we're going to consider trinomials that start with an x squared in this video. So before we talk about factoring, let's actually review how we multiply two binomials. Let's take a look at the problem x plus 3 times x plus 4. We can use the FOIL process to multiply these two binomials together. We would do first, that gives us x times x, or x squared, outer 4x, inner 3x, last is 12. Then we can combine like terms. Those middle two terms add up to 7x, and our final answer is x squared plus 7x plus 12. So I just took x plus 3, x plus 4, and I multiplied them together to get x squared plus 7x plus 12. In this video, in this unit, we're going to be factoring, and that is really working backwards from multiplication. So we'll be given the polynomial x squared plus 7x plus 12, and when we factor, our goal is to get it back into the form x plus 3, x plus 4. So to help us with the factoring, I do want to notice what happened when we multiplied. There is a pattern that happened here. The last number, the 12, came from multiplying the 3 and the 4 together. 3 times 4 gave us 12. The middle number, the 7, came from taking the middle two terms and adding them together. The 7 came from taking 3 plus 4. So in general, if you have two factors of the form x plus m, x plus n, so just x plus a number, your first term is x squared, your middle term is the sum of the m and the n, the sum of those two numbers, and the last term is the product of those two numbers. So we're going to keep that kind of rule in mind when we start doing our factoring. And so I'd like to just start by doing some examples to illustrate this pattern or this process. So let's start with the problem x squared plus 6x plus 8. So the first thing I'd like to notice is this is a trinomial, three terms. And the first term is x squared, and it's a 1x squared. There's no number in front of it. This process works when your first term is a 1x squared. So what I'm going to do is I'm going to try to find two numbers that have a sum of the middle number, that add up to the middle number, and a product or multiply to the last number. So I want to find two numbers with a sum of 6 and a product of 8. And the way to do that is to start with the product and just make a list of all the different factors of 8. How can you multiply numbers together to get 8? And so I kind of like going in order. I start with 1, so we could do 1 times 8, and then we could do 2 times 4, and that's it. 3 doesn't go into 8, so we've covered all our bases. So 1 times 8 or 2 times 4, and then I just check which one of these add up to 6. Oh, it's the 2 times 4. So what that tells me is I can factor this as x plus 2, x plus 4. I can use those two numbers and fill them into my factors. If you wanted to check your work, you could use FOIL and you could multiply out x plus 2, x plus 4, and you should get the polynomial that we started with. All right, what if we have minus signs in there? Let's try y squared minus 10y plus 9. This is a trinomial, and the leading term, the first term, is a 1y squared. So I want to find two numbers that have a sum of negative 10. So you can just put the negative sign into the problem. Sum of negative 10 and a product of 9. So I'm going to start with that product. How can I get a product of 9? Well, it could be 1 and 9 or 3 and 3. But how do I get these numbers to add up to negative 10? Well, 1 and 9 add up to positive 10, but notice if I make them both negative, you still have a positive product. Negative 1 times negative 9 is positive 9, and that does add up to negative 10. So if your last number is positive, but your middle number is negative, both of your numbers have to be negative. So negative 1, negative 9 are my numbers, and that makes my factors y minus 1, y minus 9. Again, you could FOIL this out and you will get the polynomial that we started with. Here's another one. X squared minus x minus 30. Trinomial, leading coefficient is 1. So I want to find two numbers that have a sum of negative 1. So that negative x technically has a negative 1 in front of it. So sum of negative 1, product of negative 30. Because the product is negative, that tells me one number is negative and one number is positive. But I'm going to start by just ignoring the negative for now and just listing my factors of 30. So how do we get a product of 30? It could be 1 and 30, 2 and 15, 3 and 10, 5 and 6. If the product is going to be negative 30, one of those numbers has to be negative. Negative 1 and positive 30, negative 2, positive 15, negative 3, positive 10, negative 5, positive 6. Or it could be the first number is positive and the second number is negative. Looking at these numbers, adding them up, none of these add up to negative 1. The closest I can get is negative 5 and positive 6 add up to positive 1. And so if I switch those signs, that should work. Positive 5 and negative 6, yeah, that does add up to negative 1. In fact, because the product was negative and the sum is negative, that tells me that the bigger numbers should be negative. So I should have actually made those second numbers negative. So positive 5, negative 6, that makes my factors x plus 5, x minus 6. Here's another one. X squared plus 3x minus 70. Before we get started, notice we have a negative product. So one number is going to be negative, one's going to be positive. And we have a positive sum. So that tells me the bigger number should be positive. So sum of positive 3, product of negative 70. So I'm going to start. Again, I like to just ignore the negatives at first to just make my list. How do I get a product of 70? And I like to go in order. So 1 and 70, and then I check, can I divide by 2? Yeah, 2 and 35. Can I divide by 3? No. Can I divide by 4? No. Oh, but I can divide by 5. 5 and 14. And then 6, no. 7 and 10. And that should be all of them. Because it's a negative product, one of these numbers has to be negative. To get a positive sum, the smaller number must be negative. And so now I just check which one of these adds up to positive 3, and that would be the last one in my list. Negative 7, positive 10. So my factors are x minus 7, x plus 10. Here's another one. A squared minus 7a plus 5. So we need sum of negative 7, product of positive 5. So how do I get a product of 5? Well, really, it can only be 1 and 5. Although I want the sum to be negative, so I guess it could be negative 1 and negative 5. That would give me a positive product, but a negative sum. But negative 1 and negative 5 is negative 6. That doesn't add up to negative 7. There's no other possibilities. And so that means this polynomial can't be factored. It's not possible to factor every single polynomial. We say that this polynomial is prime. Just like a prime number can't be factored. Here's another example. Let's see if we can factor 2z squared plus 20z plus 32. Now, before I get started, I want to point out that this problem is a little bit different than all the problems we've looked at in the past. It's different because there is a 2 in front of the squared term. It does not have a leading coefficient of 1. Because there's a 2 in front of the z squared, that means our product sum method isn't going to work in the exact same way. However, in the previous video, we learned about the idea of greatest common factors. And when we are factoring, the very first thing we should do in any factoring problem is check and see, is there a greatest common factor? Is there something that you can divide out of all of the terms? And in this case, there is. Our terms have a 2, a 20, and a 32. Those three numbers are all divisible by 2. We have a greatest common factor, or GCF, of 2. So I'm actually going to pull the 2 out before I do anything else. Pulling out a GCF first often makes the factoring much easier as you continue with the problem. So if I pull out the 2, I'm now left with z squared plus 10z plus 16. And now the trinomial left in the parentheses can be factored. It has a leading coefficient of 1, just a z squared. So we can use that product sum method. We can try to find two numbers that have a sum of 10 and a product of 16. So 16 would be 1 and 16, 2 and 8, or 4 and 4. And which one of those add up to 10? That would be the 2 and 8. So my trinomial, the thing in the parentheses, can be factored as z plus 2, z plus 8. Now when we write our final answer, it's really important that we keep that GCF in our final answer. So the answer is actually 2, z plus 2, z plus 8. That is our problem factored completely. Just happens to have 3 factors. Here's another one. I have x to the third plus 19x squared plus 60x. The very first thing I'm going to do in this problem is check and see if there's a GCF. Is there something that is present in all 3 terms? And yes, there is. All 3 of these terms have an x in them. That's my GCF. So I'm going to pull the x out front, and then I'm left with an x squared, 19x, plus 60. Now actually I have a trinomial with an x squared. This fits into my pattern. So I can find two numbers with a sum of 19 and a product of 60. So I'll start with my product of 60. It's a big list this time. Let's see, 1 and 60. Can divide by 2, 2 and 30. Divide by 3, 3 and 10. 4 and 15. 5 and 12. 6 and 10. And which one of these add up to 19? 4 and 15 do. So for my final answer, notice I keep the GCF, the x out front, and then I'll factor as x plus 4, x plus 15. All right, that was my last example. We'll continue with factoring in our next video.